I have a bit of a problem. I've been too successful in a way because I'm trying to build the simplest possible stack machine that I can. And I've done that, but it's too simple. I was hoping to explore what it'd be like to write a virtual machine and to take some code and compile it and run it on there. And I can do that with a simple calculation, but I want to make it more exciting, more interesting. Maybe I can have a quick look at what the plan is for this. So at the minute, I can do things like not A. We can say something like 1 plus 2 or 1 minus 2. We can't say minus. We can say 1 times 5. That works. Okay, some random numbers. We take that, we turn some bytecode and we run it, and that works well. But it's not a very exciting VM. So I was thinking something I definitely want are functions. So maybe we could say something like power, and it can take an argument. So we could take some value x to the power of y. I don't know how the syntax will work for this, but we could say something like, oh, we'd have to recurse for this. So it's going to be interesting. So if y is 0, so to the power of, this is going to be recursive, just to make things more fun. Maybe we shouldn't be recursive to start with. But let's look at sort of longer term. So if y is 0, then we just return the value 1. Else we can say x multiplied by power of x and y minus 1. I'll put some brackets in. I haven't really thought through what this is going to look like yet. But we could do something like that. And that's a lot more complicated than the thing I have at the moment, right? We need conditionals, things like this. We need functions, things like this. And then we're looking up variables by name. And then presumably down here, you could say something like power 2 to the 5, something like that. And now we have a call side as well. So there's a lot of work to implement this. And I've been struggling a little bit to break it down into manageable chunks, to things that I can work on for 1 hour at a time and make some realistic progress. But one thing I know I need to do is improve my parser. So that's where I'm going to start tonight. Parsing this, we kind of cheated. Or I kind of cheated. I just did the lexing stage, right? So I turned this into a series of tokens. So this 1 becomes a token that says it's a number and the value of this is 1. And then we have, I think it was a multiplication symbol. That comes back as a token. And then we have another number, which is 5. And that's all the parser is doing. And then we put it into shunting yard, which reorders it so it becomes 1, 5 multiplication. So we do reorder the tokens again to make it suitable for running on our VM, but I'm not parsing it properly. I'm not turning it into an such syntax tree. Can I speak even? So you can imagine a tree being, look at my ASCII art skills. Where are slashes? There. No, I don't know where / is. There it is. So you could say multiplication has got 2 arguments, 2 subtrees here, 1 and 5. We're not doing that kind of parsing and turning it into an AST. So I'm going to do that tonight. And I'm going to do it using Megaparsec. But really what I'm going to do is follow a little bit of this Megaparsec tutorial, particularly in lexing and then parsing expressions. We just jump ahead. This tutorial has got exactly the thing that I want and the code to do it. So I'm really going to be copying pasting this from memory, or maybe not even from memory. I might just come back and really copy and paste it. But when I've done that, I'll then need to plug it into my existing compile chain. So we'll need something which takes this AST and turns it back into, well, it's going to turn it back into operations or instructions that the underlying VM understands. But because this is so simple, the converting it back into underlying tokens is really just a case of converting it back into these tokens, and then I can use my existing translation to turn it into the opcodes. But that's the plan for tonight. Okay, so I have my parser spec. Oh, yeah, I have my parser spec. This is going to change a little bit. So instead of saying we should end up with this, we're going to do something like it should be an expression. So it's going to be something like it's going to be an expression. Let's make a comment fix that for a second. And it contains an operator, which is multiplication. Need to bracket a bit. So the expression's got an operator multiplication, and it's got a number 1 and a number 2. Right. It's going to be something like that comes out. So we'll need to change this spec to expect the right things. Obviously, the parser itself will need to change. So we're going to replace this whole thing with an expression parser. And I'm going to pull in a lot of stuff from Metaparsec and also from Control.Monad.Combinators.Expr. I can't remember what it is. Some library, which is going to do a lot of the work for me. And then also in here, we're not going to pass this into shunt. I'm going to write something which takes the output from parser, and so it'll be the AST, and converts it into a lower level representation, and then we'll still pass it into this lower, which is really translate, which will turn it into opcodes. Okay, so that's the plan. Let me start with the parser, I think. If I just jump back to here for a second. So this is what we want to end up spitting out. So this is going to be an expression. We don't have as much stuff in here, so it's not going to be a string. I haven't got negation. I haven't got subtraction or division. But apart from that, we've got, it can be a number, or it can be the sum of two other expressions, or the product of two expressions. Okay. Oh, there's whiskey. So we can say something like type expression is, so it can be a number, which has got some int value, or what other tokens do we have at the minute? Where are tokens? It can be multiplication or plus. So, oops, it can be plus, and then that takes two expressions, or it can be multiplication, which again takes two expressions. Why did I say type? It should be data. Sorry. Okay, so that's what we're going to spit out. And to spit it out, I'm going to use this make expression parser helper. And this comes from Control.Monad.Combinators.Expr. That's the thing I'm looking for. So make expression parser, you give it the term parser. So the terms for me are it's only going to be a number. That's the only thing that we can parse as a term. And then we give it a bunch of operators. So we use this table, or this stuff of this type. And they come in priority order or precedence order. And it will return to me a new parser, which I can then use to parse the full string. So yeah, example here. So their terms are, oh, we'll put parens in as well, actually, just for a bit of fun. I currently don't support parentheses, but we can easily add it because there's a helper for parentheses already, and I can just use that. Yep, and then this table, so the first thing is the highest precedence, lowest precedence, the thing that binds most tightly. And that's just for specifying the sign of numbers in this case. We don't have that. Do they have an example here? They don't have an example. Okay. This is for like, it's writing negative numbers and explicitly writing positive numbers. Then the next level of precedence is plus plus, which I'm not going to have. Then they've got multiplication and division, which bind quite tightly, and then addition and subtraction, which bind the most loosely. Yep, and then they just have little helpers here for putting stuff infix or prefix or whatever else. In the Megaparsec tutorial, they have a fuller example of all of this. So they have a way of parsing a variable, parsing an integer. They've written their own helper for parentheses. Then the list of terms is either an integer or a variable or something between parentheses. And then you just call make expression parser with their list of operators, and the operators are specified down here with their positive and negative numbers, and then their multiplication division, and then their addition and subtraction. So I'm actually just going to call, well, before I go any further, actually let's go to Cabal, because I need to tell it to import some stuff. So I might as well get that going. Here we depended on vector. We also need to depend on, is it Parser Combinator, or what was the package called? I've forgotten already. This package is called Parser Combinators. And then I run, I think it's running in the background. Okay, cool. So I'm now going to come back and copy this stuff. So I want, let me grab this for now. Let's drop that in. So p integer, that seems okay. It's going to return an expression. They called it int. Like that, so let's go for that. And then we don't have this in scope, but hopefully we can do that. Okay, so we're going to pull in, this is our module called Data.Megaparsec.Char.Lexer. And that's got a whole bunch of helpers for parsing little bits of stuff. Okay, that's our integer. I grabbed the parentheses as well. It uses between helper, which is quite handy. I think this comes from Megaparsec. So it can say, it starts with this symbol, ends with this symbol, and then it returns the thing in between. And then down here, our terms are going to be parentheses with some expression inside it. Not a variable, but maybe an integer. Okay, then we pull in this make expression parser. It's either going to be a term, which is these things we defined. Then we use this operator table, which we now need to create. So I'm going to just import that for a second. Okay. Okay. So first up in our table, our tightest binding stuff is going to be multiplication. And that is an infix operation. And I'm also going to go back and grab the way they defined this with some helpers. Oh, they defined it as binary. I might call it infix. I think it sounds cool. But I want this helper. Can I go like that? Yes, I can. Okay. So it's going to be infix, and infix takes what? It takes some text, which is the thing to match, I think, and then a name for it. No, it's not a name, sorry. It's going to take something which parses that. So it takes two expressions and returns an expression. Well, that's multiplication in this case. Okay. So I think it's going to be this. Let's say it's multiplication, and the function we're going to give it is called mult. Why is that an error? What have I done wrong here? Don't think that's an error. Generally, I think the error might be somewhere else. Okay. In the next table, I'm going to give it. I'm a bit worried because of this thing. Well, maybe infix is already named. That's why we can't use it. It is. It's gone bold. Right. That's why I called it binary. Okay, slightly better. So binary, and then I say better, like there's a lot of errors here. Let's start getting rid of them. So we'll pull that in. Couldn't match type character with text, right? Back in here. There's something, or is it default extensions? I can't remember what it is. And it would be, if it is this, it would be something like overload of strings. I'm blank there. Save that, see if it works. Same error, different error. Okay. Operator parser expression. It should be okay. Let me get rid of some more errors because it's a bit annoying. So I'm going to pull in lexing. Oh wait, this is void string. Let's change that for a start. Where's my error? Okay. Couldn't match parser void text identity int with the actual thing. What was the actual thing? M0A0 to M0A0. So some function under a monad. Probably because lexing is applied to too few arguments. Okay, let me just have a look at their definition of parser. Oh, that's right. Parsec void text should be right because that's specifying the type of the input. I can get rid of this error. Just reduce the number of errors. And now it's still upset because couldn't match type parsec t void text identity open 0. What open 0 means. I think it means it doesn't know what type it is. With actual type, tokens S1 to M1. Tokens S1 to M1 tokens S1. So what's type of between? M open, M close, MA to MA. So it should return the parser. I don't understand why that's erroring. Let me pull it in Fixel. Okay. I'm going to use it. So I would say parse p expression, no file name. And then I should be able to get rid of all of these things. Right. Different set of errors now. Well, different set of unused stuff. Let's work through these then. Okay, so we got this error is to do with the type. So I'm now going to take text in, and I'm going to return that type. So we're now working with text. Okay, its problem was p expression. Oops. No, that's one password shortcut. How do you get? There was some shortcut to get this up. I can't remember what it was. It's not mapped here. So it couldn't match expression with collect token. Okay, that makes sense now because we're not trying to do this anymore. Okay. Now, couldn't match type tokens S0 to this thing with parser B0. But this is just the thing I copied out of here. Okay. Is that okay? Not okay. And these things are, you expect operator parse expression, but you actually get something going from a list of operator parse expressions to another list of operator parse expressions, which confuses me a little bit. A lot of this confuses me. Does that help? Doesn't help, but we probably want to do it at some point anyway. So what things we're importing? We're importing Data.Megaparsec. Let me get it up for a second, and then we'll just pull it in bit by bit. Okay, that was a large part of it. So, because I was importing all of Megaparsec, I was getting the wrong definition of lexeme and symbol. But now I'm getting the correct definition, which is coming from Character.Lexer. Okay, and then the final error in here is this one. And now we're back to some nonsense. Right, okay. So lexeme is there. Now, between we need to import from Megaparsec. Let me unimport symbol from here. Oh, I think that is coming from our place. Choice is probably coming from Megaparsec. Okay, so delete that. Just make that an empty list for now. Let me get rid of that. So now it's unhappy about lexemes or lexeml decimal. Okay, I'm going to try building this up bit by bit to see where it starts breaking. So we should have access to, or maybe not yet. So we're going to import text Megaparsec, Character.Lexer, add L, and we'll import text Megaparsec Character.Lexer, and we'll pull in symbol and lexeme. Just pull in lexeme for a second. And I'll import text Megaparsec. And now we'll just pull in parsec, I think. Oh, and is it parser test or test parser? Parse test. Okay, so now I can say type parser is parser void text, no errors, we'll take text as an input. And then we can say data expression, oops, data expression is int. So I can say like int1 and I should get an expression. Oh, deriving show and equal. What's wrong with that? Oh, what's wrong with that? Come on, bracket in one place. Driving show and equal. Okay, try it again. So now we can create expressions. So now we can say int, p integer, so the parser of integers is equal to int, should be able to work this out, I think, lexeme l.decimal. I did mean that, yes, thank you. Okay, can I give it a type? I cannot. Can I give this whole thing a type? Doesn't seem right. No, that's how you do it. So the problem it has with this is it couldn't match type MA with int. Expected MA to int got MA to MA. So what happens with just lexeme decimal? Oh, L.decimal. Cannot deduce num arising from that. Okay. As an int. I don't understand why I'm getting that error. They parse test L.decimal as an int of, oops, hang on, of the number 2. That's not working either. So it's going to go back and find some examples of where they were parsing integers. So I could do something like L.lexeme. Sorry, lexeme L.decimal. Lexeme L.decimal, and then give it a number, and it should work. I think. No. Lexeme is applied to 2 key arguments, right? Where is lexeme coming from? It should be coming from oh, I need to write lexeme, don't I? I need to write lexeme, that's what it is. Okay, and symbol. Got it. I need a space consumer as well. Okay, so I missed a bunch of stuff out. Okay. There we go. Don't import lexeme. That's the answer. Or symbol. Just write them. So SC is it's a parser that returns nothing. And then it's this helper for this, so it's L dot space or something like that. I can't remember. It's L dot space, space 1. Let's grab these. Okay, I don't necessarily want line comments, but I'll leave them in for now, so I can put comments into the code. I'm going to do that though, I should probably make them batchier. Okay, that's fixed a lot of my errors. And now we fixed all of them. Okay, so the things that I didn't do correctly were I didn't define this lexeme helper. So the argument that it was missing all the time was this space helper, which is defining what the space is. And I'm saying at least one space character. I'm just playing out of the Character.Lexer. And what the line comment is and the block comment is. So I can just get them. Okay, so in theory now, Maybe now I can put my orders back in. So it was something like binary multiplication. It was mult is the thing for it, the constructor, and the other one was binary plus and then plus. Plus? Yeah, it's plus. Okay. And then binary. So it takes text. I'm going to look this up because I can't remember off the top of my head. Binary was text, expression. So text in the constructor, and then it returns this thing. Okay. Are we getting closer? Not there yet. So here, it's a table of tables, right? A list of lists, sorry. Containing an operator of parser expression. An operator table is just a list. Oh, maybe that helps. Wow. Okay. I didn't have a list of lists. I was applying one to the other. Right. Now this file compiles without any problems. This one compiles, but I should have errors if I go back to here. Doesn't work out. And also actually in here. It's not going to compile, so it won't run a test for me. Okay. Let's go here, and we'll just make this undefined for a second. Oh, is it now going to complain because I'm not using stuff? Yeah. Oh, I've made this too strict. I can just say left nothing. Not quite. Try right nothing. Oh, right empty list. Okay, cool. And this is not used, so I need to ignore it. Okay, now I can run my test. I want to see the test failing. Guess that's good. So it doesn't parse. Is it going to tell me what it did get? Okay, I give it list collect tokens and it expects parse expressions, so it just is never going to work. So what I think this should be is expression. So the expression that we get back is actually a multiplication. No, it's not a multiplication at all, it's a plus. And it should have int 1 and int 2. That's what I think it should be. Okay. Annoyingly, they've called it int. So let's import. Import calc parser as it is, but we're also going to import. Oh, actually, go back to here for a second. We're not exporting the expression. So now we should be able to say import parser as p. and this will be p.plus and p.int and p.int, and I probably want to put the word qualified in there. Okay, so if I run the test again, virtual parser does not export int. It does not, it's correct, and now it does. Okay, so the second one's failing, but the first one's passing. So now we can do this one as well. So this should be, what's this going to be? This is going to be p.mult of the left-hand side of this is p.plus of p.int 1, and then p.int 2, and then the right-hand side is just p.int 3. I think it is not. That was as a show, okay, or equal. I've got to do that here. Deriving, oh, that's no, show and equal. Exit code, fail. Oh, it doesn't work. Okay, it doesn't work, which is fine. But the parser itself does fail with something interesting. So I got the order of this wrong. So the way this comes back is, of course, because multiplication binds tighter. So it's going to be p.plus on top of my tree, and then to the left is p.int of 1. And the right-hand side is a multiplication of 2 and 3. See if that works. So we're still going to get failures, but I'm hoping we only get failures when we run the calculator. Yes. So the parser is now passing. It's good. Okay. What next? I can do parentheses. I can't spell parentheses. 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 Goodness, I don't know how to spell that. That might be fine. So we should be able to say calc parser. Same things above, so we put this time with parentheses, so we can say 1 plus 2 times 3, and that should be the answer I put in before, and I got it wrong. So now we should have p.mult as the outside, because the bracket's going to bind tighter. So on the left-hand side, now we have p.plus, and we have p.int 1 and p.int 2. On the right-hand side, we have p.int 3. See if that works. Yes, it does. So parser parentheses, okay. Okay. So that works okay. Now we need to work out how to lower it, or how to turn it into a list of tokens. So I'm just going to stick it in here for now. I don't know where it should end up. but we'll have something here called lower, and it will go from an expression to a list of calc tokens. So, how do we do this? I guess recursively. So we'll start at a very simple case where we have int x is it tnum x? Oh, an empty list of tnum x. Not an empty list, sorry, a singleton list of tnum x. Okay. What if it's plus? We'll then have left and right. And what we do, I think, is we lower left and then we join it to lower of right, and then we put t plus at the end. And then the final one, I think, is if we have multiply and left and right, same pattern, so lower left, lower right, and this time t mult. Okay, and then we can export this. And then back in here, import qualified parser is p, and we're going to call p.lower, and this time we will pass in the output from calc parser. I'm going to take a text. Is it going to take a text? Yes, but this is also text. Okay, once I run the tests, out of curiosity, it passed. So I'll scroll up. Oh, you can't see the output if it passes. That's annoying. I wish it always told the output. Cool. So we have now replaced our previous just string out a list of tokens to something that turns it into an well, it's a single expression in this case, but it's still a tree structure. So it's still an abstract syntax tree, just with one node in it, or one, one expression in it. But it still works, right? We can still convert it into our bytecode and have that execute. So we could say something like it can calculate a complex expression or an expression with parentheses. I hope that's spelled correctly. So calc of, let's do something a bit more complicated. So we could do some things above, I guess. So you say 1 times, but then bracket 2 plus 9. Should be right, and then 2 plus 9. It's still going to be, that's still very boring. Let's do this to make it more interesting. Obviously it fails, so that's going to be 4 9s, so we say 6, and this is going to be 2 11s, which is 22. Let's make sure that works. Something failed. Oh, it's not 4 nines. It's 4 plus 9. Okay, now it passes. Good. Okay, so we can put brackets into here as well. That's cool. I've maybe got 10 minutes left, so let's say it can subtract numbers. So calc of 9 minus 5, and this should be 4. Should be right. Oops. Right of 4. And in fact, it's going to be left of not being able to parse it properly. Left of some complicated error. Oh, that's interesting. Right. There's a bug in my parser. It rejects invalid input. So calc of 12 ABC. That's not a thing it knows how to parse yet. Should be left, and the type of left is a little bit complicated, so it's going to be left of one of these things. Parser bundle text void, but I think parser bundle is quite complicated in itself. But let's say left invalid. Not quite what it's going to give me back. No, that's awkward. So I need to look up the contents of the type of parse error bundle. Non-empty collection of parse errors. Non-empty parse errors, and the parse error this is such a nightmare. So it could be a trivial error, int. That's really annoying. Is there anything nice that we have in here to turn it into? I can turn it to string or pretty print it. Show error component. We could try show error component, I guess. I just want to be left something. Left error is equal to. We're going to do, so we might need to say let. Left error is calc of 12 ABC, and then we can say error should be, it's not going to be empty string, but let me just See how far we get with this. Notice for is string of this. Okay, so if we say something like show error component. This is implement show error component. I'm confused now. Error pretty bundle. Error bundle pretty gives me back a string. I'm not importing that, and it's not going to help me. Why isn't it helping me? Text dot Megaparsec. What's it called now? Error bundle pretty. And this is just a megaparsec. Text megaparsec error. That's a megaparsec, and that's not in the command file for this. Let me just put it expensive everything. Right. I mean, that's kind of where I wanted to be. So it should be a left error, but it's not. It's a right something. Opposite, is it stopping because it's not exhaustive? Can we say is left? So it's something like let result be that. Is left a result should be true. And then we can just try that. It's not the math is going to work. Let me see if this even works. Yes, okay, so it's not coming back with any error. I guess that's good enough. Right, it means I can fix it basically. So we should have written this in the parser spec as well. It rejects invalid input. It's a calc parser of 1, 2, 3 ABC. It's something like should not parse, or let's find out what we have alongside should parse. Should parse is in here. Should fail with. complicated, just should fail. So it should fail on is that the best I can do? Yeah. So it should fail on A basically. Or it should fail on, and then maybe ABC, I think it's going to fail on. What have I done wrong here? Calc parser string should fail on that. Oh, parse, that thing should fail on. No. I guess not. I don't want to test the RMS itself, I just want to see that it does not succeed. Now I'm calling parse later down, I don't need to call it here. Oops, so calc parser, what's that returning to me? It goes from text. So it's calling parse the expression, so parse the the parser, empty string, no file name, and then I'm passing in the text. And it's the same thing here, so parse the parser, empty string. Oh. Okay, so I just say calc parser should fill on 1, 2, 3 ABC. So this test should fail as well. Rejection value input, expects true or false. Parse rejection value input, parse expected to fail, but it parsed it. It's int 1, 2, 3. That's the error message looking for. Right. Quick fix for this. Quickish fix. So there should be nothing at the end of the string, basically. That's what I'm saying. Okay, now we have a single failing thing. So everything else is passing, but we say we can subtract numbers. We expected it to be right 4, but we got some error saying it couldn't parse it. Okay, how am I doing? I'm running out of time. I'm not sure I'm going to do it. I'm not sure I've got time to do all the subtraction, but oops, let's give it a go. How long will it take, right? So parse the subtraction. Let's do 2 minus 1. We'll keep things positive here, and it should be t sub, and then 2, and then 1. It should be really easy to add, I think. So we can also be subtract, expression, and expression. Then we just add to a list of operators. So that can be binary, subtract, oops, and sub. And down here, this is subtract in here, and then this becomes t sub. So another type error. So this is in tokens. It's going to be t sub. Just following the errors basically. And now we go to calc. So lower of, oops, of t sub. I guess it's going to be 0x04, just because of the way things have worked out. So VM. Oh, unexpected instruction. Okay, that's a good thing to get to, I think. So we expect everything to pass except that it can't subtract. So instead of write 4, we get write unexpected instruction. Okay, that's quite nice. So now we can say 4. This doesn't really know me. So we're going to do subtraction, which is a copy of this. I do want to simplify this, but I'm not going to have time. Definitely not going to have time today. So subtraction. Subtract these things and not enough values for subtraction. Not all the tests pass apart from one. I got -4. Okay, apparently we can't do negative numbers. No. Subtraction is, no, the ordering should be the same. So we should have pushed 2 values onto the stack. And it should be the first number we push and then the second. But we are reversing everything. Okay, reverse Polish, I need to be careful when the values are not commutative. So the order in which, I mean, technically this is wrong. VM. Technically that's wrong. It's actually y plus x. The thing is that it's commutative, so it doesn't matter. So I'm getting it wrong. Simple multiplication. But I have a problem with division as well. So the way to get pushed on, if it's 9 minus 5, x is set to 5, and this is set to 9. So I need to be very careful about how I'm pulling stuff off, in the order in which I'm evaluating them. Okay, cool. Anyway, that works. So I've now successfully created a parse tree, an object syntax tree. I turn it back into list tokens. Then we convert the tokens into opcodes, and then we run the opcodes, and we have added subtraction as well, just for fun, and we've got brackets as well. Okay, cool. So next week, I will continue to enhance this in some manageable way. But yeah, thanks for watching, and hopefully see you next week. Goodbye.